Hi, in this video we will discuss about improving a semantic search with reverse hypothetical document embeddings. This is one of the technique where we are going to use how we can improve the semantic search. Okay, so we are discussing about retrieval augmented generation in detail. So in the previous video we discussed about the processes and how we can improve the chunking using different chunking strategies, and then in continuation of that one, we are going to discuss today about improving semantic search, especially using with reverse hypothetical document embeddings. Reverse in the sense like we are going to do the opposite what actually proposed by hypothetical document embeddings that I will show you. Yeah. So now the main problem we face is that the semantic gap between queries and the documents. In many real world applications, there is a fundamental mismatch between how the user usually asks questions and how document will provide answers. Okay, so sometimes there will be a lengthy document, and then the user will be asking a specific or a twisted question where there is no direct semantic meaning, or there may not be a direct answer available in the document. So in such cases, it will be a little bit difficult to retrieve the correct chunk or the document piece, and then if you can't able to retrieve correctly, then obviously you don't get a correct answer in the augmentation phase. So now let us see an example. So now the user asks the query. They are often short and to the point they will ask. Okay, it will be usually in a conversational language and focus on a specific piece of information. Example like how much did 3M make in year 2018? So this is a very concise and a specific answer was required for this particular question. But the documents, which is often long and formal and dense with information, so the answer might be somewhere found in the table or somewhere in the graph or somewhere situated where it is not directly implied that this is how much it make. So in that cases, even for a very good generative model couldn't be able to retrieve properly if you don't have the base foundation of a proper document chunking and having that semantically indexed, then it will be a very big issue. So now we are trying to make that particular gap narrow, such that when a user asks the query, there will be more related documents, like easily to pick the documents to related to that query, so that we can achieve by using this reverse hypothetical document embeddings. Okay, so now you can see the difference between is known as the semantic gap. If you take a standard vector search, it may struggle to connect that user's financial query with a formal document. Okay, so this is how like I just you can imagine, like we have a query and then there is a document, and if there is a query and document mismatch, definitely we have a difference in the answer. So the retrieval system couldn't be able to grasp that particular semantic meaning or the exact meaning what the user asked, and then it can't able to reproduce the answers based upon the given, because it couldn't be able to match the correct documents, then obviously it won't be able to get the answer. So that's why the user query style and document style is totally different. Like there is a huge gap between those two, and then definitely we don't get the correct answer. So now the solution what we are proposing here is that reverse HYDE, HYDE. So HYDE stands for hypothetical document embeddings. Okay, this will generate better signposts. Okay, so reverse HYDE. What is reverse HYDE or reverse hypothetical document embeddings? Is a technique designed to bridge this semantic gap. How we are doing? Okay, so instead of indexing a raw document, we use a powerful language model to generate several hypothetical questions at the document. Okay, that will be a perfect answer for. Okay, for example, we have a document, and then we pass the document to the LLM. That LLM will generate possible questions to this particular document. Okay, that means what are the questions can be asked on this document. Okay, so we get those questions. So that is what we call it as reverse hypothetical document embedding. Okay, So that document would perfect answer for when we then create vector embeddings for each of these questions to use them as a pointers to the original document. Okay, so we vectorize these questions and then we point to that particular document for all these questions. So this is a reverse hypothetical document embeddings. The original solution was hypothetical document embedding. I will show you here like what it actually means. So here this is the paper they propose. So what they say is that you can go through the paper. Is this the okay? Let me see. Yeah. Okay, this is the hypothetical document embedding. So what they propose here is that given a query, the hypothetical document embedding first zero-shot prompts as an instruction following language model like instruct GPT or whatever it is to generate a hypothetical document for the questions. So the document captures relevance patterns, but it is fake and may contain hallucinations. Okay, then an unsupervised controversially learned encoder. So these are all most technical things. So the most what actually they want to do or they want to accomplish is that when a user asks the question, this is for hypothetical document embeddings. When a user asks the questions, that questions, let us assume the user asks the question, that question will be passed to a large language model, and that large language model will generate fake answers, okay, to that questions. So that is called hypothetical document embedding. So then with that fake answers they try to match with the real document. So this is a very lengthy process where it takes some time in the initial setup, and also significantly they increased the percentage of retrieval accuracy. But we are going one step further where we do reverse HYDE. Instead of creating a fake documents, we directly create the questions based upon the documents. Okay, so nothing, we are not doing anything fake as is in the hypothetical document embedding. Like they do a stage where they create the fake document, and then from that they try to get the actual document chunk, so that semantically meaning, and then they do the embedding of those things. So now we are not going to in that way, in that route. If you want to know much about hypothetical document embeddings, you can just click into the link, and you can, and there is a video also attached to that one, so you can get explanation for that one. But what we are doing here is that we are directly doing the opposite way, where we create a set of questions, okay, based upon the given chunk. So we pass the document. Instead of passing the user query, which is in hypothetical document embedding, we pass the document itself, okay, or the document, and then that document will create, from the document we create a set of questions, and that questions will be taken as an index or a flag post. So those questions will be vectorized, and that will be indexed for that particular chunk or a particular document. Okay, so this is how we are going to proceed. So now I'll explain detail here. Okay, just give me a second. Okay, so here, so this we already discussed. The solution is reverse HYDE. So reverse hypothetical document embeddings is an advanced technique designed to bridge this semantic gap. Okay, we already discussed why we have a semantic gap. Instead of just indexing the raw document, okay, we first use powerful language model to generate several hypothetical questions that the document would be a perfect answer for. Okay, so we are going to generate several questions based upon this original document or chunk. We then create vector embeddings for each of these questions and use them as pointers to the original document. Okay, so these questions will be embedded into vectors, and these questions will be as a flag post, and this will be pointing to the original, this particular document chunk, from where we get the questions. So this is how we do implementation reverse HYDE. Raw document, okay, generate hypothetical question, create embedding, and then you do the reverse embedding. Okay. So a concrete example. So this is how we can do for financial document especially. So the original document, we have the answer, and generating, let us assume this is a chunk, and then we generate hypothetical questions from by passing this chunk to LLM, and then we get the questions. Okay. Now indexing the questions and not the document. Okay. So now we embed the questions and place it in a vector database, and that will be index, and that index will be pointing this particular document chunk. Okay. So now this is the way we do, and I will show you in the demo how exactly we do that one. So this will okay, this is the actual thing where I copied from the demo. Okay, so now how this bridges the gap. Okay, now when a user asks a real world question like what is the comprehensive income attributable to 3M in the year 2018 and how does it compare to the previous 2 years, the system converts this query into vector. Okay, obviously the user query will be converted into vector. The vector will be semantically very close to our generated questions because it will search on the questions, because we only embedded the questions. Okay, so semantically similar question it will search. If it can find the semantically similar question, then that will be the document where it will pass to the LLM. So now we reduce the hallucinations more way far below, because we are matching questions with questions. That's it. We are not matching questions with the document or anything else, but as we did in the IDE, like hypothetical document embedding. So we are matching question with the question. So it is concise, and then we can get more related questions, and then we pick either top 3 or top 5 or whatever we want, and then pass it to the LLM, and then the LLM will generate the final augmented answer. So this is about Reverse HYDE. So this is what we discussed already. So we have unindexed document chunks, generate questions, index questions, and index question vectors. Okay, facilitate accurate retrieval information. So this is how we implement Reverse HYDE. So one key advantages over hypothetical document embedding is that it is not, there is no impact on space speed, because we do the reverse part. Instead of creating a hypothetical document for, or a fake document for the given question, which is originally proposed by hypothetical document embedding, we do the reverse. We create we pass the document and create the questions, and do the questions embedded in the vector database. And while searching, it is very easy. We are matching question to question. That's it. So it is crucial to understand why it is called reverse hypothetical document embedding, because original hypothetical document embedding is slow. Generate a hypothetical document from the user's query at a search time. This adds latency. Okay, because of the user has to wait for LLM to generate text. So it has to generate long text, even though it is fake, for generate a question. Then they will try to match. Okay, so that we are not doing. We are doing the reverse of the one, okay, which is fast. Generates hypothetical questions first, and then from the document during the initial indexing phase itself. So we are not doing anything while user asks the question. Okay, whenever there is a new document, or we are doing a RAG process, like we want to do RAG process for a given documents, at that time the initial process will take some time, because it has to generate questions, and then question has to be embedded and then point to a correct document. So that is done. Once that setup is done, when a user asks the query, it is directly going to match with questions, and then get the answers. So Reverse HYDE is fast, generates hypothetical question from the documents during one time, that is indexing phase. That's it. Because all heavy lifting, the LLM generation is done upfront. Okay, while doing the initial document ingestion phase itself, like in the RAG data pipeline, the user search remains incredibly fast, because whenever user searches the query to query matching only. So you get a benefit of dramatically improved accuracy without sacrificing your speed. That's one thing. So here I already discussed what is HYDE. So HYDE uses a large language model to create a hypothetical document responding to the query, as opposed to the query and its computer vector directly seek the vector database. But it is going, okay, so these are all technical details in depth about HYDE, which is I will share the link so that you can have a deep dive on that one if you want to know further. So we already discussed why we go for Reverse HYDE. Comparatively, it is faster and more efficient process. Okay. So now we will see the demo for reverse hypothetical document embeddings. Okay, so these things we already discussed, like we create a better signposts. What are the signposts? These are the hypothetical questions for the document. So we generate questions based upon the given document, and from that questions only we are going to index it, okay, instead of the actual proposed hypothetical document where they create a fake document from the user question while doing the search. So we're not doing that one, so we are doing the reverse of that one. So now as usual, we want to visualize the output more clearly and elegant, so that's why I use this theme manager and all. So this is just for those things, and use a doc theme. So now this is the actual reverse hypothetical document implementation, okay. So I imported the required libraries, and then I'm using Google Colab here. So there is a way you can save this, save the secrets, and then call it in the Colab notebook. This that's what I did here, and then so now this is where the implementation starts, okay. So I'm using OpenAI text embedding ADA 002 model, and then getting the embeddings, okay, for embedding the questions, and then generate reverse HYDE. So how we are doing, like, you know, so there I'm just giving a simple prompt here. This is what actually it does. So given the following text chunk, generate n different questions. So here I given a default of 20 questions. It depends upon your use case, like how much you want. By default it has to be generated, so it can be 5, it can be 10, or how much questions you want. You can set it as a default here, and then and I'm pausing the chunk, okay. So chunk means the actual document chunk. So what we are doing, so we are pausing the document chunk, and then asking the LLM, powerful LLM, such that you need to give, I am pausing the chunk, you need to give the answers. How many answers you need, you can define here, and questions, not answers. So you pause the document, and you will ask questions, and it will give the questions back to you, and then that questions will be embedded, and each question will be treated as an index for this particular document chunk in the database, okay, vector database. So this is what I did. So simple, calling the client, and then asking like I'm pausing the document with a prompt, and then asking the questions, okay. So generate the questions, this many number of questions for the given document chunk, okay. Okay, so temperature I given 0.7 in order to get more given some freedom to generate the questions, okay. We are going to generate the questions based upon the given document chunk only. So this is our document, which is the actual context, in the sense, like the LLM is not going to deviate from this document. From this document only it is going to generate the answers while generating the questions, okay. So while generating the questions, it should not, we will give some liberty or freedom to generate different questions. Since I given 20 as a default, so I given a little bit freedom to generate more questions. So that's why I chosen temperature 0.7. That you can tune based upon a use case and the number of questions you want to generate. Okay, so that's it. So then process chunks, and then we will get the okay. So you cannot go. So it takes no need. I think we already have the answers as well. So no need to connect. Okay. So now we, from this we can generate the questions. Okay. So passing the chunk, and then for each chunk it has to generate the reverse HYDE. That means questions for the given chunk. Okay. So now I'm having the API key here, and then passing it the chunks. So here I took 3 different. This example we already discussed in 1 or 2 videos, but I'm taking the same example. I have created 3 different chunks. Okay, the chunks look maybe a little bit bigger, so I want to test the actual the accuracy. So I given 3 different chunks. as a simple text, and then I'm pausing it and I'm processing it, and then I gave the default the default is 20, and also asked for 20 questions. So it processed, you can see here, so this is the output we got. So it processed the 3 chunks. Okay, this is the first chunk here. Okay, so this is the first chunk, and then it processed the first chunk and it generated the questions. Okay, so these are all the questions it generated. Okay, so let me show you. Okay, so I use GPT 3.5 turbo. This is more than enough for our use case, but if you have any specific use case where it is more related to your domain, then you can use your own fine-tuned model here, or it depends upon use case, like which one you want to use, to get more relevant questions or more domain specific questions. So that's what I want to show there. Like here, this is what we had discussed. So we have the questions here. So these are 20 questions generated for this particular document chunk. Okay, so this gives all the questions. These are the possible questions that the user can ask based upon the given document chunk. Now user asks questions more related to this any of these 20 questions, then that will be matched, and then it will pull this particular document and then give it to the LLM to answer the user query. So this is what we are going to achieve. So same way I paused the second chunk, and then the second chunk we got the questions here. So you can see the questions. What are the company's significant contractual obligation for December 2020, 2018, and how much total debit does the company currently have outstanding, and what are the payments due to here. So here, if you can see that even I didn't go for a GPT-4 or something more superior model. If you can observe that it catches that financial context, like so, then it created the questions more, which is for good enough, like for our use case. But if you want to further fine tune, as I said before, you can either use fine tuned model to get the to create the questions, or you can give a more elaborate prompt, like you are a financial analyst, or you are dealing with mergers and acquisitions, or you are dealing with mortgage related thing, and you can give a elaborate prompt like how the question should be framed, and you can also give zero shot examples, like if this is a chunk and this is questions you can give. So those are the ways how you can improve the output of the LLM. So we already discussed the way you ask questions, and the way you expect answers from the LLM. If you can clearly describe that one in the prompt, then it will be very easy for the LLM to give you the expected results. Okay, so now if you can see here, I didn't specify anything special here in the program. If you can see here, given the following text chunk, generate n different questions that this chunk would be a good answer to. That's it, nothing else. Here you can give a more detailed prompt, like you are a financial analyst, you are dealing with these things, and then you have this much of knowledge and all those stuff. Like you can give more elaborately, and also give some few small chunk, 3-4 paragraph chunk, and then what will be the possible answers for those chunk, and then if you give some examples as well, then you will get more appropriate questions generated for the given chunk. So this is for just demonstration purpose. I just given a straight direct prompt, but even that one was working as expected. So that's what I want to show. So 20 questions has been generated here, and then we have these questions. Okay, questions with the chunk. So now I just add a query here, like what was the value of the defined benefit pension and post-retirement plans adjustment in 2016. Somewhat a little bit of complex query, and in order to test that, I used in-memory quadrant vector database. There are there is a video where I show you actually how you can do in a production like setting, where we can run a code run database in a separate cluster, and then using an API you can connect it, and then do the settings, all those things. So this is just for demo purpose, for especially to demo hypothetical document embedding, the reverse part of the reverse hypothetical document embedding. So same thing. So in memory, and I'm using all mini LLM L6 V2 for embeddings, create embeddings. Okay. So I create. So we need to create a collection. So that is Reverse HYDE, the collection name. Okay. So here vector says almost 384 is the dimension for that particular all mini LLM L6 V2. So it depends upon that particular. So you can plug in whatever transformer you want. So based upon that, it will get the vector dimensions. Okay. So now I'm just creating some point like metadata. So document ID, and all those stuff, and then I'm creating the embeddings. Okay. So this is the collection here. So what actually it means, and then this is the size, like a vector size. So now we created the collection like vector embeddings. Okay. So now we are going to okay. So collection name. Okay. Get collection. Okay. Consolidated. Okay. So we already did this, and so we are doing here. We do the vectorize. Okay. Points, model point struct. So ID vector is the question. So we are doing questions. We got the questions, and we are going to embed only the questions, and this will be the index for the document. Okay. So now just for visualization, that is the question I asked. Like, what is the question here? Query first. What was the value of the defined benefit pension and post-retirement plans adjustment in 2016? Okay. So this is just getting the best document to match. Okay. So that is the question, and then best matching chunk is 3M and subsidies considered statement. So this is the chunk. So this is maybe the first chunk, I think. Yeah, that's the first chunk. So this is the chunk which it can get answer from that one. Okay. So how this is that we are not pausing anything to augmentation phase, just we are hitting it and getting the answer. That's it. Okay. So this is like, just directly querying the database, vector database. So what happens, the user query will be sent, and then it will be embedded, and that embedded user question will be semantically searched in the index for the given questions, which is already we did in the first phase while doing the creating the vector index, and then the matched user query and the matched semantically matching the index will be matched, and then from that we pull the document, and this is what it is giving, like having the score of 0.8960. This is without embedding also I tried. It fetched the same, but you can see the score difference here. So this one greatly changes the accuracy. Okay. So it is 0.45, but here it is 0.8960. Even though the chunk is correct, but the score is very, very less. Sometimes it may, since the core is less, it may not consider this as a correct chunk. Okay. So now I tried the different questions as well. What is the company expected market risk related to foreign currency exchange rates, interest rates, and commodity prices? So with reverse ID and without reverse ID, these are the matchings. You can see the vastly the difference. And I checked this is the correct chunk for that particular question also. And what was the declared dividend per share for the year ended 31st 2018? Okay, this is the chunk it gave. Okay, so now okay, ID collection. Okay, so this is reverse ID with reverse ID. Now now we have the collection, that is the vector database, and we can get the exact answer by sending this chunk and user query to augment and get the correct exact answer. So then the previous we just saw like directly hitting the vector database and getting the chunk. That's it. So now we try to get the exact answer based upon the given chunk. Okay. Based on the following chunk, answer the question. If the question is not present in the text, state the you can't find the answer. That's it. Okay. So this is a simple function to get the correct answer. That's it. Okay. So temperature I gave 0.1. To get more factual numbers, we need to make it very low. If you give more liberty to or more freedom to the generative model, it can deviate, but it depends upon the use case how you can you are managing it. So you can tune that one. Okay, so this is a specific collection, and then it goes and eats that, and then get the collection and writes you and gives you the output. I just decorated with some visually appealing outputs here. So if you can see here, first I'm collecting hitting the collection and getting the best match found record, and then augmenting, like you need to pass a chunk and a question to the large language model to answer it, right? So what was the value different benefit pension plan rate post retirement plan adjustment in 2016? It is 524 million. Okay, this I cross verified it was correct. And then the another question what I extracted, what is the company's exposure to market risk related to foreign exchange rates, interest rates, and commodity prices? This is a question asked, and it paused with the relevant chunk, and it gave a clear detailed answer. The company is exposed to market risk related to foreign currency exchange rate, interest rates, and commodity prices. Foreign currency exchange rates may affect the company's net investment in foreign subsidiaries and cash flows related to foreign denominated transactions. So it gave the answer, the exact answer, like what we want to get. Like now this is a most typical question to give the exact number. Okay, what was the declared dividend per share for the year ended December 31st 2018? The declared dividend per share for the year ended December 31st 2018 was 5.44 per share. Okay, this is also correct. I cross verified it. So yeah, so these are all typical number answers that I cross checked, and those are all correct. So this is how we can further enhance the accuracy of retrieval augmented generation. So in this particular video, we discussed about reverse HYDE. Reverse HYDE means reverse hypothetical document embeddings. So hypothetical document embeddings was the original proposed system to enhance the accuracy, but we do the reverse of that one. Instead of creating a fake document while the user was asking, and then doing the further processes, that will take more time, and it may not be as good as the reverse HYDE. So in the reverse HYDE, what we do while doing in the initial setup itself, like while pausing the document itself, like while doing the embedding, we generate we do the chunks, and then we pass the chunks to the LLM, and then we generate questions, set of questions based upon your requirement, and then that questions will be embedded, and those questions will be a flag post for the documents or for the given chunk, and that will be indexed in the vector database. When user asks the query, that query will be embedded, and the query to query matching will be done, and once that matching is done, get the most semantically matched queries based upon your user. You can go for either k equal to 5, 7 or 10, and then all those chunks will be passed to an LLM, and then you get the answer. So this will drastically improve the accuracy of retrieval augmented generation. Okay, yeah, thank you for watching, and we will discuss further enhancements like hybrid search, re-ranking, and multimodal retrieval in upcoming videos. Thank you.